You know the feeling, right? You open up your downloads folder, and it's just a complete disaster. A digital graveyard. You've got a dozen files all named something like final report, underscore V3, underscore final, underscore I promise this is the last one. It's pure chaos. But what if? What if you could just teach your computer to clean up its own mess?
Well, that is exactly what we are going to do today. We're going to build your very first Python script to automate all that annoying digital housekeeping. So forget about all that manual renaming and the endless, mind-numbing drag and drop. Let's make the computer do the work for us. So here's our game plan for today. First, we're going to give Python some real control over your computer's file system. Then, we'll learn how to find the exact files we need to work with. After that, we'll make our script interactive so we can give it instructions on the fly. We'll even see how scripts can talk to other programs. And finally, we'll pull it all together and build our very first super powerful automation tool.
And you know what the best part is? You don't have to go out and hunt down a bunch of complicated tools to do any of this. Python was designed with what they call a batteries-included philosophy. And that just means that all the powerful tools we need to manage our files, they're already built right in, ready to go, straight out of the box. So let's jump right into Section 1, System Superpowers. This is where we learn how to give our Python code direct control over the computer itself. We're letting it do the same things you'd normally do with your mouse, but, automatically. Okay, so our most fundamental tool here is the OS module. You can think of it like a direct phone line to your operating system. After a simple import OS, you can ask your script things like, hey, what folder am I in right now with os.getcwd? Or you can tell it to navigate somewhere else with os.chdr. You can even create brand new folders just like you would by right-clicking. It's incredibly powerful stuff. But for the really common tasks, Python gives us an even friendlier tool, the shootle module. It's just a more intuitive way to work. Want to copy a file? It's one command, shootle.copyfile. Need to move a whole folder? Shootle.move. It just handles all the nitty-gritty details for you, so you can focus on the big picture. Okay, so we can make folders, we can move files. That's cool, but how do we find the right files to manage in the first place? That brings us right to Section 2, Finding and Managing Files. This is where we learn to find those needles in our digital haystack. For this little bit of magic, we have another fantastic built-in tool, the glob module. This lets you search for files using patterns. You see that little asterisk in star.py? That's a wildcard. It basically just means match any characters at all. So this one little line of code is asking the computer, hey, can you find me every single file in this folder that ends with .py? And boom, here's what you get back. After you run that glob command, Python just hands you this nice, clean list of all the matching file names. Instantly, you have a targeted list of files that your script can then loop through and process one by one. It's simple, it's fast, and it is the foundation of so many automation scripts. So you can see how we can start combining these tools into a really clear, logical process. To rename a whole batch of files, the steps are pretty much always the same. First, you find the files with glob, then you plan out what their new names will be, and finally, you execute the rename with shootle.move. Find, plan, execute. It's a really simple and powerful pattern. All right, now for Section 3, Building a Command Line Tool. You see, a script that just does one thing is useful, sure, but a script that you could adapt on the fly, that's a true power tool. We're about to give our script its own little control panel, which will let us give it instructions from the command line without ever having to touch the code itself. Python gives us two main ways to handle this. The first one is sys.rv. It's simple, but it's also kind of crude. It just gives you a raw list of whatever the user typed. For anything remotely serious, we use argparse. It's this super sophisticated parser that lets you define exactly what your script needs. You can make sure the data is the right type, and my favorite part, it can automatically create helpful instructions for anyone who uses your tool. Let me show you how it works. With argparse, you basically define the rules for your script's input. So that first argument, file names, tells the script to expect a list of one or more files to work on. The second one, colon lines, defines an optional setting. We tell it to expect a number, and if the user doesn't give it one, it'll just default to 10. Now, check out how argparse translates what the user types into structured data for our script. In that first row, the user just gives it two file names. Notice how argparse automatically applies our default of 10 for the lines? But in the second row, the user overrides that default by setting dash lines to 5. argparse handles all of this parsing for us, giving our code a clean, easy-to-use little package to work with. This is really what turns a simple script into a professional tool. This leads us right into Section 4, speaking the language of data. See, our automation scripts don't live in a bubble. A lot of the time, you'll want to generate a report of what you changed, or maybe read a list of files to process from a spreadsheet. To do any of that, our scripts need to speak a common language with other programs.
And that common language is called a data interchange format. It sounds a little technical, but it's a simple idea. It's just a standard way of structuring text so that totally different applications, even ones written in different programming languages, can reliably understand and share information with each other.
One of the most common formats you'll see is CSV, which just stands for comma-separated values. Honestly, if you've ever worked with a spreadsheet, you already know this format. It's just a simple row and column structure. It's perfect for structured data, and Python's built-in CSV module makes reading and writing these files an absolute breeze.
Another hugely popular format is JSON. Instead of rows and columns, it uses a system of key value pairs. This is fantastic for representing more complex, kind of nested data structures, which is why you see it all over the web. And just like with CSV, Python has a built-in JSON module that makes working with it super simple.
And that brings us to the grand finale, our final section, building your first real automation script. We are going to take everything we've just learned, the file operations, the searching, the command line arguments, the data formats, and combine it all into one powerful working tool. So here is the blueprint. Step 1, we use argparse to get our instructions from the user. What files are we looking for and what should we rename them to? Step 2, we use glob to find all the files that match that pattern. Steps 3 and 4, we're going to loop through everything we found using shootle.move to rename each file. And then, for that final professional touch in Step 5, we'll write a clean CSV log file that documents every single change the script made. And that's really the journey. We've gone from looking at a messy folder to designing a complete, reusable automation tool in just a few minutes, all using those batteries that come included with Python. You now have the blueprint to solve your own digital clutter problems. So the only question I have left for you is, what tedious, repetitive, annoying task will you automate first?